Hey guys, we're going to be going over note card number 18, which is the quotient rule. Okay, you guys should already have this in your packet, okay? So if you remember the formula, this is the one that I use for you guys to help you guys remember. So it's high, and I'm going to put hoe here, which is the gardening tool, okay? All right, here we have the formula is going to be hoe, and then times the derivative of the top, which is high, minus high times the derivative of the bottom, which is d hoe, okay, over hoe squared. Okay, so if we apply this formula to the first question, which is given that you have this function t squared over 3t squared minus 2t plus 1, find the derivative of this function. Okay, so we're going to apply this rule. So hoe is the bottom, so 3t squared minus 2t plus 1 times the derivative of the top, which is 2t, minus high, which is 2t, t squared times the derivative of the bottom, which is 6t minus 2, over whole squared, which is 3t squared minus 2t plus 1 squared. Now, once again, we can distribute all this stuff and simplify it, but just for time's sake, I'm going to go ahead and move on to the next question, okay? All right, the next one's saying, what is the instantaneous rate of change at x equals 2 of the function f, given that f of x is equal to x squared minus 2 over x minus 1. So we want to know IROC at x equals 2. Okay, so that means to take the derivative. So it's going to be hoe, which is x minus 1, times d high, which is the top. So the derivative of the top is 2x, minus high, which is x squared minus 2, times the derivative of the bottom, which is 1, so times 1, over the bottom squared, so x minus 1 squared. So here what I recommend is for you guys not to simplify this if you're going to plug a number in, okay, because you can make a mistake with your simplification and then your whole answer be wrong, okay? So let's go ahead and plug in 2 just from here. So 2 minus 1 is 1, times 2 times 2 is 4, minus 2 squared is 4, minus 2 is 2, times 1, over 2 minus 1 is 1, 1 squared is 1. So here we get 4 minus 2, which is 2. Okay, simple as that. All right, the next one is, suppose that we have f of 5 equal to 1, f prime of 5 equal to 6, g of 5 equal to negative 3, and g prime of 5 equal to 2. So what it's asking for is find the derivative of g divided by f of 5. Okay, so just a little refresher. Okay, if I leave this as a function, the formula is going to be hoe, so it's going to be f of x times the derivative of the top, which is d high, so g prime of x, minus high, which is g of x, times the derivative of the bottom, which is f prime of x, over f of x squared. So we're going to use that formula, okay? So let's go ahead and replace the x's with 5's. So it's going to be g divided by g divided by f prime of 5 is equal to f of 5 times g prime of 5 minus g of 5 times g prime of 5 over f of 5 squared. So here we just simply need to substitute these values that we already have, okay? So f of 5 is 1, so 1 times g prime of 5 is 2, minus g of 5 is negative 3, okay, times f prime of 5 is 6, over f of 5 is 1, and then that's squared, okay? This becomes a plus sign. So we get 2, 1 times 2 is 2, plus 18 over 1, which is a 20, okay? All right, and then the last one, here we have, it says find the slope of the normal line. So for number 4, we want to find the slope of the normal, and I like to put the subscript so I can remember that I need to have the normal slope, okay? So here we have we want to find the slope of the normal line to this graph. So this function, 3 sine of x over 4 plus cosine of x. And we want to find the slope at x equals negative pi over 2. So it's going to require us to do the quotient rule, okay? So once again, it's going to be ho. So 4 plus cosine of x. And then the derivative of the top, so d high, which is 3 cosine of x, minus, so it's ho d high minus high, so 3 sine of x, times d ho. So the derivative of this is going to be negative sine of x, because the derivative of 4 is 0, and the derivative of cosine is negative sine, over 4 plus cosine of x squared, okay? So here's what we need to do. We need to evaluate this derivative of negative pi over 2. So I'm going to go ahead and, as a side note, what we can do is we can basically plug in negative pi over 2 into cosine. So if you remember in the unit circle, the clockwise direction is the negative. For negative pi over 2, we're going clockwise direction. And the x value there is 0, okay? For sine of negative pi over 2, the y value here is negative 1. So here we're going to be plugging in negative 1s and 0s, okay? So this becomes a 0. So we get 4. And here this becomes a 0, so times 0, minus 3 times negative 1 when we plug in the negative pi over 2, times negative, because the negative is already there, and then that results also in negative 1, okay? Divided by, we already know that's a 0, so 4 squared only, okay, because it's squared up here. All right, so we know that this cancels out, that one just becomes 0, and we have 4 negatives, which turns into a positive, okay? So we're only going to multiply the numbers, so we end up getting a 3 on top and a 16 on the bottom. And that's your final answer for, actually, you know what? This is for the tangent line. Okay, so that's the slope of the tangent. We want the slope of the normal, so it's the opposite reciprocal, so it's negative 16 over 3. And that's your final answer right there.